Hello students, welcome back to JJ's physics class. In the previous class, we started doing revision on wave optics. Today we will be continuing with remaining questions. So let us start. Question number 22. Why does sun appear red at sunrise and sunset? So it is due to the scattering of light. As per Rayleigh scattering, the amount of light scattered is inversely proportional to fourth power of the wavelength. If it is a two-marker question, you can explain this part. Next question, number 23. A beam of unpolarized light is incident on the boundary between two transparent media at an angle of incidence is equal to IB, which is the Brewster's angle. At what angle does the reflected light get polarized? So here the answer is, when the reflected wave is perpendicular to the refracted wave, it is completely polarized. In detail, we can explain that at a particular angle of incidence, the reflected light and the refracted lights are perpendicular to each other. That angle of incidence is known as the polarizing angle. Question number 24. State one feature by which the phenomenon of interference can be distinguished from that of diffraction. Sub-question. A parallel beam of light of wavelength 600 nanometer is incident normally on a slit width A. If the distance between the slits and the screen is 0.8 meter and the distance of second order maximum from the center of the screen is 15 millimeter, calculate the width of this slit. First part of the question, you can give any difference between interference and diffraction. So in interference, all the maxima are of equal intensity, but in diffraction pattern, central fringe is of maximum intensity while intensity of secondary maxima falls rapidly. And the numerical answer is, you can calculate the width d is equal to 80 micrometer. Here all the units must be converted into meter. Question number 25. Define linearly polarized light. When does the intensity of transmitted light becomes maximum? When a Polaroid sheet is rotated between two cross Polaroids. What is linearly polarized light? The light having vibrations of electric field vector in only one direction perpendicular to the direction of propagation of light is called plane or linearly polarized light. Intensity is maximum when sine 2 theta is equal to 1 or theta is equal to 45 degree. So you can show this derivation. Then you can say that the transmitted intensity will be maximum when theta is equal to pi by 4 or theta is equal to 45 degree. Question number 26. How does the angular separation between fringes in single slit diffraction experiment change when the distance of separation between slit and screen is double? The answer is theta is equal to beta by d, where beta is the fringe width. So d lambda d by d. So d will get cancelled, so it will be lambda by d. So theta is independent of d, angular separation will be remains constant. So when the distance d of separation between the slit and the screen is double, the angular separation remains unchanged. Question number 27. Why are coherent sources necessary to produce a sustained interference pattern? Second question. In X double slit experiment, using monochromatic light of wavelength X, the intensity of light at a point on the screen where the path difference is X is K units. Find out the intensity of light at a point where the path difference is 2 lambda by 3. Answer to first question is, coherent sources have a constant phase difference and therefore produce a sustained interference pattern. The sources are needed to ensure that the position of maxima and minima do not change with time. This is the derivation for the second part. Then you can say that the intensity of light at a point where the path difference is 2 lambda by 3 is k by 4. Question number 28. State two conditions required for obtaining coherent sources. In Young's arrangement to produce interference pattern, show that dark and bright fringes appearing on the screen are equally spaced. Answer to first question. Two conditions for obtaining coherent sources. The coherent sources of light must have originated from a single source, must be monochromatic in nature. The path difference between the light waves from the two sources must be small. Third point, coherent source of light should be obtained from a single source by some device. And second part of this question, we know that the fringe width for dark and bright band is given by beta is equal to lambda d by d, and it is same for both dark and bright fringes, so they are equally spaced on the screen. Question number 29. Answer the following questions. In a double slit experiment using light of wavelength 600 nanometer, the angular width of the fringe formed on a distant screen is 0.1 degree. Find the spacing between the two slits. Second part, light of wavelength 5000 angstrom propagating in air gets partially reflected from the surface of water. How will the wavelengths and frequencies of the reflected and refracted light be affected? Answer is, we can calculate the spacing between two slits using the formula d is equal to lambda by theta, and you get it as 0.34 millimeter. Second part of the question, for reflected light, wavelength and frequency remains the same, but for refracted light, wavelength decreases but frequency remains the same. Question number 30. Yellow light of wavelength 600 angstrom illuminates a single slit of width 1 into 10 power of minus 4 meter. Calculate the distance between two dark lines on either side of the central maximum when the diffraction pattern is viewed on a screen kept at 1.5 meter away from the slit. Second one, the angular spread of the first diffraction minimum. Answer is, distance between two dark lines on either side of the central maxima is 2 lambda d by a. So if you calculate that, you get it as 18 millimeter. Second part is, angular spread of the first diffraction minima on either side is theta is equal to lambda by a, which gives 6 into 10 power of minus 3 radians. Question number 31. A parallel beam of light of 500 nanometer falls on a narrow slit and the resulting diffraction pattern is observed on a screen 1 meter away. It is observed that the first minimum is at 2.5 millimeter from the center of the screen. Calculate the width of the slit. Answer is, you have the formula n lambda is equal to d sine theta or a sine theta. Substitute the values, you get it as 0.2 millimeter. Question number 32. A parallel beam of light of 600 nanometer falls on a narrow slit and the resulting diffraction pattern is observed on a screen 1.2 meter away. It is observed that the first minimum is at a distance of 3 millimeter from the center of the screen. Calculate the width of the slit. Here the answer is, again using the formula, n lambda is equal to a sine theta or d sine theta. You get it as a is equal to 0.24 millimeter. Question number 33. Answer the following questions. In what way is diffraction from each slit related to the interference pattern in a double slit experiment? Second part. When a tiny circular obstacle is placed in path of light from a distant source, a bright spot is seen at the center of the shadow of the obstacle. Explain why. Answer to first part. The intensity of minima for diffraction is never zero, while for interference it is generally zero. Second point is, all bright fringes for diffraction are not of uniform intensity, while for interference these are of uniform intensity. And answer to the second part, waves from the distant source are diffracted by the edge of the circular obstacle, and these diffracted waves interfere constructively at the center of the obstacle shadow, producing a bright spot. Question number 34. For a single slit of width A, the first minimum of the interference pattern of a monochromatic light of wavelength lambda occurs at an angle of lambda by A. At the same angle of lambda by A, we get a maximum for two narrow slits separately by a distance A. Explain. So you need to Write down for a single slit of width A, the nth minimum is sine theta n is equal to n lambda by A, and show this and prove that angle theta is equal to x by d, which is equal to lambda by d or lambda by A. You can write this as the explanation. Question number 36. Find an expression for intensity of transmitted light when a Polaroid sheet is rotated between two cross Polaroid. In which position of the Polaroid sheet will the transmitted intensity be maximum? Answer is, let the rotating Polaroid sheet makes an angle theta with the first Polaroid. Therefore, the angle with the other Polaroid will be 90 minus theta. Then apply Malus law. Then you can show that the transmitted intensity will be maximum when theta is equal to pi by 4. Question number 37. Unpolarized light is passed through a Polaroid P1. When this polarized beam passes through another Polaroid P2, and if the pass axis of P2 makes angle theta with the pass axis of P1, then write the expression for the polarized beam passing through P2. Second part is draw a plot showing the variation of intensity when theta varies from 0 to 2 pi. Answer to first part is I naught is the intensity of unpolarized light. Then the intensity of polarized light from P1 is I1 is equal to I naught by 2. When this is passed through another Polaroid P2, intensity of polarized light from P2 is I2 is I1 cos square theta. As theta varied from 0 to 2 pi, so we obtain I2 versus theta as shown here. Theta is varied from 0 to 2 pi. Question number 38. In a single slit diffraction experiment, when a tiny circular obstacle is placed in the path of light from a distant source, a bright spot is seen at the center of the shadow of the obstacle. Explain why. State 2 points of difference between the interference pattern obtained in Young's double slit experiment and the diffraction pattern due to a single slit. Answer is, the wave diffracted at the edge of circular obstacle produces constructive interference at the center of the shadow, producing a bright spot. You can write any two difference between interference and diffraction. Question number 39. In Young's double slit experiment, monochromatic light of wavelength 630 nanometer illuminates the pair of slits and produces an interference pattern in which two consecutive bright fringes are separated by 8.1 millimeter. Another source of monochromatic light produces the interference pattern in which the two consecutive bright fringes are separated by 7.2 millimeter. Find the wavelength of light from the second source. What is the effect on the interference fringes if the monochromatic source is replaced by a source of white light? First part of this question, the wavelength of light from the second source is given by lambda 2, which is equal to 560 nanometer. So we have the fringe width formula for beta 1 and beta 2. Then equate these two equations. You get lambda 2 as 560 millimeter. So you can write this explanation for the second part. Question number 40. In a single slit diffraction experiment, a slit of width d is illuminated by red light of wavelength 650 nanometer. For what value of d will the first minimum fall at an angle of diffraction of 30 degree? Second question, the first maximum fall at an angle of diffraction of 30 degree. Second sub-question, why does the intensity of the secondary maximum becomes less as compared to the central maximum? Answer to first part is, first minimum fall at an angle of diffraction of 30 degree, d is equal to 1300 nanometer. Using the formula n lambda is equal to d sin theta. Similarly, calculate for the first maximum fall 2n plus 1 lambda by 2 is equal to d sin theta. Then you get it as 1950 nanometer. Answer to the second part is, the central maximum is due to constructive interference of secondary wavelets from all parts of the slit. Question number 41. In Young's double slit experiment, The two slits 0.15 millimeter apart are illuminated by monochromatic light of wavelength 450 nanometer. The screen is 1 meter away from the slits. A. Find the distance of the second sub-question bright fringe, dark fringe from the central maximum. And B. How will the fringe pattern change if the screen is moved away from the slits? For the first part, the distance of the second bright fringe is y is equal to n lambda d by d. Substitute the values, you get it as 6 millimeter. Second one, dark fringe from the central maximum will be y is equal to 2n minus 1 lambda d by 2d. Substitute the values, you get it as 4.5 millimeter. Second part of the question, linear width of the fringe is beta is equal to lambda d by d and angular width is equal to lambda by d. With increase in the value of d, linear width will increase while the angular width will remain the same. Question number 42. Explain by drawing a suitable diagram that the interference pattern in a double slit is actually a superposition of single slit diffraction from each slit. Write two basic features which distinguish the interference pattern from those seen in a coherently illuminated single slit. The diagram given here shows several fringes due to double slit interference contained in a broad diffraction peak, that's at this point. When the separation between the slit is large compared to their width, the diffraction pattern becomes very flat and we observe the two slit interference pattern. So basic features of distinction between interference and diffraction pattern are as follows. So you can write any two differences. Question number 43. The ratio of the widths of two slits in Young's double slits experiment is 4:1. Evaluate the ratio of intensities at maxima and minima in the interference pattern. Sub-question. Does the appearance of bright and dark fringes in the interference pattern violate in any way conservation of energy? The answer to first part is, for maxima the intensity is 9K, for minima intensity is K. So the ratio is 9:1. According to law of conservation of energy states that the total energy of the system remains constant. The formation of bright and dark fringes does not violate law of conservation of energy because energy is only transferred to the points of constructive interference from the points of destructive interference, but the total energy always remains constant. Question number 44. Good quality sunglasses made of Polaroid are preferred over ordinary colored glasses. Justify your answer. Answer is, the intensity of light transmitted by Polaroid glasses is also low and is more effective in reducing the glare due to reflections from horizontal surfaces. Question number 45. State laws of Malus. Draw a graph showing the variation of intensity I of polarized light transmitted by an analyzer with angle theta between polarizer and analyzer. Next question. What is the value of refractive index of a medium of polarizing angle 60 degree? Laws of Malus statement is given here and the equation is I is equal to I naught cos square theta and variation of intensity with theta is given by this graph. And last part, mu is equal to tan IB, so tan 60 degree which is equal to root. Question number 46. Define the term wavefront. State Huygens principle. Next question. Consider a plane wavefront incident on a thin convex lens. Draw a proper diagram to show how the incident wavefront transverses through the lens and after refraction focuses on the focal point of the lens, giving the shape of the emergent wavefront. So here the answer is, definition is locus of all points which oscillates in phase. And Huygens principle, these are the two statements. And refraction of a plane wavefront from a convex lens is given by this diagram. So these are the plane wavefront, convex lens, and these are the spherical transverse wavefront. Thank you, students.